Okay, so this online lecture is meant to go over with you the concept of center of mass, both mathematically and conceptually. So basic definition of center of mass, this is the average location of all of the mass in a system. And you can define what your system is, okay? So sometimes you may want to just concentrate these three objects to be one object interacting with a different object, and you define what the system is. Sometimes it's called the center of gravity. But they are equivalent to each other. And something to note that is that if an object does not have a support force underneath its center of mass, it will be unstable. So if an object does not have a support force underneath its center of mass, it will not be stable. Okay, so it will be unbalanced. And so there is a mathematical model for center of mass, and the equation is relatively straightforward. It's this idea that the center of mass of an object is equal to the sum of the object's mass times its location. Okay? So you're going to take each object, multiply it to where it's located, and then add them up. And then this is divided by the sum of the masses. So I being like, I is 1 through 3 or 1 through 5. However many objects you are defining to be in your system. Okay? So it is the sum of the product of the mass times its location divided by the sum of the masses. So let's just look at a pretty straightforward example that is in your workbook. You have a picture of it. Essentially, in this example, you have one object that is 5 kilograms, and it's defined to be at the 0 mark. And then a second object is at the 8.5 meter mark here. And it has a mass of 10 kilograms. So in applying this equation, the center of mass, the location of the center of mass, is going to be my mass 1, which is 5, times its position, which is, it's at the 0 point, so it's going to be 5 times 0, plus my second mass, so mass of 10, times its location of 8.5, and then divide that by the sum of the masses. So this is going to be divided by 5 plus 10. So my center of mass is going to be then 85 divided by 15. And pretty straightforward. That comes out to be 5.37 meters. So if I think about like where that is on my system, here's 0, 1, 2, 3, 4, 5, 5.37. It's probably around like here, like that's my center of mass right there. That's my point. And it makes sense that the center of mass of this system is closer to the heavier weight, the more massive weight than it is the lighter weight. So it's a pretty straightforward equation, and mentally it should kind of be pretty straightforward. We are just going to look at the calculation of systems that are linear. You could go into depth and look at like where there's an x center of mass and a y center of mass, and then actually do like a Pythagorean theorem. But we are not going to go into that complexity. We are just looking at like if I have a linear system, where the center of mass is. And it's helpful to kind of think about things in terms of their center of mass, because if there's no net external forces acting on the system, then the center of mass of that system should stay the same throughout the object's like movement or whatever. Okay. So hopefully that gives you a more mathematical understanding of center of mass.